Okay, so this is the 2020 DEB pre-paper for the junior cert, and I'm going to do question 4, which is the developments question. And just before we start, anything I do in red will be construction, and anything I do in black is in heavy. Okay, so we're presented with a cut cone and also the development of a cylinder. So we're presented with the elevation and the end view. So we're going to go ahead and draw that to start with. Okay, so it's this question here, question 4. So first things first, I'm going to start my elevation. So what I normally start with is just a horizontal line across the page. Okay, so that's just something to work off. So first things first, we're told the width of our elevation is 80. So I'll come in and I'll mark my elevation. So it's 80, and we're told the right hand side 10 mil. So I'll draw that, and there's also another measurement of 20 mil in from that, so I'll just put that in here to save us time later on. So I'm just going to complete the elevation. So as I said, anything you see in red is construction, so keep it nice and light with a sharp pencil on your page. And the height of our elevation is 80. So there is an end view, so I'm just going to bring the height across as well. Okay, so we're told in the end view that the radius of the cone is going to be 70. So what I'll do is I'll actually find halfway here first so that I can measure. So that's the center of the cone almost. So I'll bring that across as well. And I'm just going to put in that radius 70. So I'll measure up 35 and down 35 from the center, and that'll give me that 70 that I'm looking for. So there's 35 down the way, and then you can measure up to that 70. And I'm actually going to bring that the whole way across for the end view as well. Right, and okay, and that goes to the top here. Okay, so you can see that that's the cone starting to develop. And just to find that cut part, so we're told that there's an angle of 30 degrees from this line here. So what we're going to have to do there is we're going to have to use our 30-60 degree set square. You don't need to measure with a protractor. Just use your 30-60 degree set square. So if we were to look at it as a 90-degree angle, if we're told that this angle here is 30, so that's what they're after giving us, the remainder must be 60. So we're just going to go off at 60 degrees. And that's from that interval. So when we stepped in 20, so just bring that up to your cone. And then from there you can go off at 60 degrees, and that'll find that cut part. Okay, so that angle there is 30 degrees, so that's why I use 60 on my set square. Perfect. Okay, so we're told then for that little bit of cylindrical part, we're told that, see that 54? That's very important. So we're going to take that in our compass, and we're just going to scribe an arc, and that's going to intersect that horizontal line we just have to draw. So to get 54 on your compass, measure along a line. Don't just pick at random, or don't measure on your set square. I'd rather you pick a line. So I'm just going to go down here and just going to measure 54, make a little mark. So from this point, there's 54, and then put your compass on that. Do not come along and measure on your, I don't want to see you doing this, because number one, you'll destroy the set square. Number two, it's not as accurate. So use it, measure a line, use it as scaffolding almost. There you are, there's your 54, and then come down and just scribe an arc so it hits that horizontal line. And there you'll see Yeah, we're after finding that point. So I'm going to go ahead and join the dots and just draw that. So that's the left hand side of that cylindrical surface. And then just use sliding set squares then to find the narrower part of it. So you can set it up so it's parallel to that line you just drew and then bring it across. And there you have it. Okay. So that's the elevation drawing. Do you know what? I'm gonna put that in heavy. Just the parts that we know we can commit to. Right. Just focus that again. Okay, so I'm gonna put in lines in heavy, which I'm happy with. Okay, so that's our elevation drawn, and it's looking good. And I'm just going to label it their surface A, and we have our surface B down here. Perfect. Okay, so we're going to go ahead and draw our end view. I'm going to draw it 20 mm across. Should be plenty. So 20 mm, and we know the full width of it. The bottom is 80. So just measure 80 across, and then two vertical lines. Sorry. Alright, so that's the extreme widths of the end view. And then I'm just going to find halfway, find the center, and we're told the smaller radius, or the radius to the bottom of the cone, as we said earlier, was 70. And because we brought those over from our elevation already, so you see we brought it over already, we can just draw that. There's no measurements needed. So nice thing, it should be there. Okay, there you are. So we're going to have to find the circle here, which is the cut part of where the cylinder and the cone actually intersect. So what I'm going to do is I'm just going to bring across that line, and to find the center, I'm just going to bisect it. So as always, extend your compass greater than halfway, scribe an arc either side of the line, keeping the same distance on your compass, go to the other side, and just scribe your two arcs to intersect those two previous arcs just drawn, and then join those arcs, and there we are. That's the center of that circle of our end view, and I'm just going to go ahead and draw that. Yeah, okay, so if you're comfortable with all what I've done so far, and there's no harm if you want to fire ahead and drive on without me, and skip forward to the development part. Don't have me holding you back. And that's our end view done as well. I'm just going to put that in heavy just to avoid confusion later on. Okay, and I'm just going to try to put these circles in a bit heavier for you just so you guys can see them. Okay, so that's hidden detail, this smaller circle, the inside, and then the larger one. Right. Okay, so we're going back. So that's our end view and our elevation drawn, and we're at 11 minutes in, so we're going well. So we're going to attempt to develop the cone first. So we're actually given the true length of one side, so what I'm just going to do is I'm going to work off the elevation because that'll help me to work a bit quicker, and you'll see in a second why. So first things first, just take that as if it's a full cone and just scribe an arc. Alright, nice and big. Alright, we don't know where to stop here, so what we have to do is we go to our end view where we're given the cone at basically the true shape of the base, and we're just going to 60-30 that. So do that the whole way around. So be careful here, we're working from the center of the cone now. Do not work from the center of the smaller circle. It's very important. It's an easy mistake that could be made in an exam situation as well. So we're developing the cone. Okay, and now what we got to do is we just take the width of one of those intervals. Alright, you don't need to take them all separately, just take one because they're all the same, and just mark it off from your elevation 12 times. So actually start on your elevation, okay? And just mark that off 12 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and last but not least 12. Alright, and no harm, label those points. So here will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what you'll find is you'll have two number ones. Okay, and the reason for that is when you actually develop the surface, your number one will be where the seam is, and by seam I mean where the development can be joined back together. You can actually go ahead and join the center of that to all these points, because we need to mark off along these generators the heights, because you can see the cone is cut. It's not a development of a full cone, so we're actually going to have to try and locate points along these lines. So join the center out to all of these points that we located, to 12 of them. Alright, so we're still working nice and light because I'm in red. We're using a sharp pencil and it's nice and light. Lovely. Okay, so that's the cone actually developed, but what we don't have is the true shape of it almost. So that's just like the scaffolding, that's just like the construction of it. So now we need to actually locate these heights here. But firstly we need to locate these generators on the cone itself and then find where they intersect the cut. Okay, so we've already drawn our generators over here. So what we can do is we can bring them over and join them up to the apex of the cone. What I want you to do is I want to be able to join this cone or create the development, but what you want to do is use as much material. So if we were to actually construct this or make this cone itself after being cut, what you'd like to do is have as much material being used in here. Okay, so if we're in a factory, you want most of the material to be used here, and then the seam to be on either side using the least amount of material. So as you can see, if we were to cut the cone, the least amount of material is here. So we're gonna make this generator here, so the smaller part, number 1, alright, because that's on the far side of the cone almost, or where the seam will be. So I'm gonna make this 1 down here. Alright, so that's very important. So I'm labeling this generator here number 1, and then you can work anti-clockwise or clockwise. It doesn't necessarily matter. I'm going to work clockwise. So number your end view the whole way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, that's 11 there. And then that's 12 there. Sorry about that. So that's not a point. Right. So what you got to do is bring those generators over to your elevation. So you'll see I'm not going the whole way across my end view. There's no need, because you'll see 2 and 12 are actually on the same line. So I'll extend it there and show you. So they're 2 and 12 are on the same line, so there's no need. I'm just going to label them here. So that's 1, 2, and 12. Next one up, we have 3 and 11, 4, 10, 5 and 9, 6 and 8, and at the top is just 7. Okay, so what you got to do then is draw the generators on the cone itself. So that's 2 and 12, and you see 2 and 12 intersect the cut right there. 3 and 4, you can do it after the rest of them. So join all these points to the top. 4 and 10 is done already for us. 5 and 9, and then 6 and 8 to the top. Now, here's the mistake that everyone will do, or a lot of people might do, is people could take, so for instance, if we were to take 5, you can't just take that distance there and mark it over on 5, because that is not a true length. Alright, that is not a true length. So it's actually foreshortened, because 0.5 is actually closer to us. So we need to find the true length of it, and in order to find the true length, all you got to do is bring 0.5 to the edge, because the edge of the cone is obviously a true length. The far left of the cone and the far right of the cone are true lengths. So you need to bring, so there's 5 for instance. There's 5 brought over. Then you can take your compass and extend it to 0.5. Okay, and then you go around to 5 and mark it off like that. Okay, so what you got to do is, where 5 intersects the cut, just bring it parallel to the base of the cone, to the edge. Then you take that distance from the apex of the cone and mark it off on your 5 of your development. So that there is 0.5. Alright, what you'll notice is 5 and 9 are the same distance, so I can just take that distance and mark it at 9 as well. So there you are, there's 9, and you need to do that for all the points. So I've already brought 5 and 9, so there's 6 and 8 where they intersect the cut, right there. So 4 and 10, bring it over to the edge. So you're just bringing them parallel to the base, wherever they hit the cut of the cone. Just bring them parallel to the base of the cone. And then what you can do is just take those distances. So 1 is actually on the extreme left of the cone, so you can just take that distance. So that's 1. So, and we've marked 1 here at the start and at the bottom, or at the far side of the cone, sorry. Okay, so what I've done there, right, just to slow it down a bit, so because 1 is on the left hand side of the cone, that is a true length. So I can just take that distance of my compass, and I have 1 here starting, so I'll just mark 1 there, and on the same on the left hand side or the end of the development almost. So that there is my seam. Okay, so that's where, if we were to actually manufacture this, it would be joined there at 1. Right, so that's the smallest amount of material used here, and the greatest amount will be in the middle of the development. Right, so that's point 1. Now we're going to find point 2. Now, a lot of people might just come in here, oh yeah, there's the generator, and mark it down. That's not correct. We needed to bring 2 across, and there's 2. Alright, so it's on the extreme part of the cone, so that is the true length. So 2 and 12 are on the same height, so I'm just going to mark 2, and I'm going to swing it around, and I'm actually going to mark 12 as well. Okay, same thing with, I'm going to drive on now, 3. Alright, so a lot of people do that mistake. No, you need to go to the end. There's 3 and 11, so bring it in, mark 3, swing it around, and mark 11. And we're starting to make some progress. So there's 3, 11, 4 and 10. Sorry, that's 6 there. 4 and 10. 5 and 9. We've done that. We've already done. Oh, sorry. We've already done 5 and 9. And so we're going to move to 6 and 8. This will hit the cut. There you go. So I'm getting my heights from the extreme part of the cone now. I'm not getting from where they actually make the cut, I'm bringing them across. So that's 7. Okay. And you'll see your development is actually, the curve is starting to come together. Alright, so I'm just going to join the dots here. I'm going to do it in red first, nice construction. I'll do it in pencil and then I'll go over it in black. So this is where you should use a freehand sketch, nice and light. Okay. And there you have it. And I'm just going to put in the seam on the left hand side. And that's your development there. So this is surface A. Alright, yeah, so that's surface A there. Alright, and I'll just go over and heavy with my compass just to show you a bit better. Okay, and that's the development of surface A done. So you'll see the seam starts there and there. So there's 1 and the whole way across. Okay, so now we need to develop the cylinder. So what we'll do is we'll project perpendicular to one of the edges, or to this longer edge, sorry. Alright, so what we'll do is we'll use sliding set squares. So this is the development of the cylindrical surface. So we're going to project perpendicular. So to project perpendicular, you need to set up one of your set squares so it's parallel to the larger edge. Right, so you'll see there, set up parallel, and then slide it, and then it'll be perpendicular. So I'm just going to bring it down here. So set it up so it's parallel, and then slide and set squares, and bring the smaller part rather than that. Okay. So to develop a cylinder, you need to 60-30 the plan of it, okay, and mark that off 12 times. Okay. But what we don't have is a plan. So what we're going to do is we're going to look, if we were to look vertically down, we wouldn't be getting a true width. It wouldn't be, you'd be getting from here to here, which isn't the width of the cylinder, whereas we need to look that way. Okay, so we need to look parallel to this edge here. So if you were to imagine that was a cylinder sitting like that, you'd have to look basically perpendicular to the top surface. So what we're going to do is we're going to draw a plan of it first. So same situation. I don't know what we can do it this way. set up so we're parallel to the left hand side edge, and you can just go parallel and then set up a perpendicular line. That's the start. So this is called an auxiliary. So what you gotta do, you know what, we should run that line a bit further down and you'll see why. So I'll do it here. Alright, so that's just a random perpendicular line, and so the plan of the cylinder is somewhere here. So to find our center point, we need to bisect this line. Okay, so some of you might be like, what am I doing now? So I'll show you more details. There's the center. Right. So to take us back, I'll draw the okay, so what we're doing, I'll use a nice green color to show you. Okay, so what I'll do is I'll sketch it. So if we were to look at okay, so if you can just imagine that that's our cylinder there, and if we were to look, if you were to stand up here and look that way at the cylinder, what you'll see is just a circle. But what we don't have is the center of the circle, so that's why I just bisected the line over here and that found our center. So that's basically what we're trying to achieve, and then we're going to 60-30 that circle. Alright, so you can see, so I don't want to do it over the drawing, but that section there, so basically what we have in our drawing itself is something like that. Okay, so that's what we have, and I'm just going to take it as a full cylinder, so that there can be represented there, and what I'm going to do is I'm going to pretend it's a full cylinder, and then I'm going to find the cut. So that's why I'm drawing this auxiliary here of the cylinder. Basically it's an auxiliary plan because we're being projected from the elevation, and so I'm going to go ahead and draw this auxiliary plan of it. Okay, so we're going okay for time. We're at 28 minutes and we should be motoring on now. Right, so that's the auxiliary plan, so that's the circle. So that'll tell me how far I need to come across for the height of the cylinder over here, or for the distance over here. So I just extended them on when I, yeah. So I'm going to start the development of the, I'll just start it here, it's just a random line. So I don't know the length of the cylinder, so that's why we need the 60-30 here, like this, and we're going to take one of those distances and mark it off 12 times. So in order to go 60-30, okay, so there's one I'm drawing for us. So be careful here, because it's at an angle, set up you need to set up your 60-30 so it's parallel to the center. So see that center line? I just set up my 30-60 set square parallel to that because I want those lines to intersect, because it'll It'll help you later on. So you can go ahead and draw the rest of them then. But keep your anchor there. Keep that 45-degree set square there. It'll help you. Okay, so one more. And then... Okay, sorry. So just be careful when you're 36 doing that circle, that you're not just as if it was a vertical cylinder. Alright, so you have to do it at an angle. Alright, so use your sliding set squares. Okay, so if we were to, similar situation with the seam, okay, so I want my seam to be here, the smallest part of the material. First things first, I'll actually mark it off 12 times before we talk about that. So just take one of the intervals. So I just took that distance there on the circle and just mark that off 12 times over here. Eight, 9, 10, 11, and that's 12. Okay, so there's my 12 parts, and I'm just going to put in vertical lines for each of those because I need to find where the cuts are, and I'm going to use each of those intervals. Alright, nice and light with a sharp pencil. And 12, and just number them 1 to 12. Similarly, we'll have 2 number 1s because that's how our seam is. Alright, so I want my seam to be here. So I'm just going to number this one here, number 1 there. Because that little dot there I'm just drawn, so see that little dot I've just drawn? That is represented by that line there. And I'm just going to go clockwise again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and you need to just bring those points up to the elevation then. So again, sliding set squares. So you'll see now why we set up our set squares for our 60-30 to circle, because 6 and 8 will intersect together. Bring those up. 5 and 9. 4 and 10. Alright, so that's the center. 3 and 11, they're on the same line. See, this makes our life a lot easier when we get to this stage. So now what we got to do is where they hit the cut, just bring them down. So let's set up one of my lines like an anchor, or one of my set squares, sorry. And I'll just bring each of these down. Okay, so you'll see. So wherever you hit that cut of the cylinder, just bring your points down. We'll have to extend them more in our developing area, but we'll do that in a sec. Have we brought ready? So notice how again I'm not going back over myself. I started at the top and I'm working my way down, so I'm not going back over my last line, which is going to avoid smudge as much as possible. Right, and then that's the last one. Okay, so sorry, I'm just going to extend these on while we're down here. Okay, so we're actually nearly there, and we're at 35 minutes, so we're on the ball, and obviously you'll be able to move a lot quicker than me because I'm talking through concepts and stuff. Okay, now let's join the dots. So we just need to locate these. So right, okay, so 1 is, so there's the width of 1. So when you come up here, find line 1, and there's 1. So see how I did that? So I just came up, there's 1, came up, and there's the line there. So it hits here. That's 1, and you can do that on the other side as well. So there's the width of 1. And what you'll find is, so here's 2 and 12. So 2, so when you hit here, there it is there. So what you'll find is you can actually just work your way in. So you're stepping up 1 and in 1 every time. And 7 is only there once, stepping down 1 and in 1 on the other side then as well. So then you're just going to have to join the dots in the end. Yeah, so that's all the points located. So how we did that, 60-30, the plan, each of those points then, so for 5 for instance, to find that point, 5 and 9 up here, okay, so so I hit here, followed that in, so I'm still looking for 5, so I followed that in, and there's 5 there, and it's also on 9 as well, so there's 9, so that's why I locate, but I just went through them because I knew where they were. But that's how we found each of them if you were to go through it slowly. Right, and then you're just join the dots. So that's why I wanted the seam to be at the furthest point left and right of the development, because we're trying to use the least amount of material as possible, and when we are, if we were to manufacture this. Okay, we want to be maximizing the use of our material as much as possible if we were manufacturing this. So that is surface B, that's the cylinder developed. So that is the question completed in full. So just look back at our questions, make sure we've answered everything. So we've drawn the elevation of the end view, we've drawn the development of the conical surface A, so that's that there, and we've drawn the development of surface B, which was kind of tricky, but we got there. So any questions, as I said, feel free to throw me a comment or whatever, and I'll hopefully get back to you. So thanks for watching.